Hello everyone, let's solve workbook question number 20, which is a beautiful question to work upon. Sir, this is the question. I strongly recommend that first you solve it by yourself, then we will work upon it together. Okay. Before solving this question, let me solve another question. Sir, unsigned int a is equal to -2 printf %d comma a. Okay, sir, since it is a question of unsigned int, sir, let us talk about cyclic property. Let's recall cyclic property. Sir, if this circle represents unsigned integers, that means %u, and if I assume that integer take 2 bytes, that means 16 bits, sir, what are the values? Sir, 0, 1, 2, 3, 3, 2, 7, 6, 7, then 3, 2, 7, 6, 8 till 6, 5, 5, 3, 5. Done, sir? Sir, the equivalent circle in signed integer, sir, it start from 0, 1, 2. In positive, it goes till 3, 2, 7, 6, 7. For negative, we move like this, -1, -2, -3, -4 till -3, 2, 7, 6, 8. Okay, sir. So, see, sir, one variable is created with the name A. We are trying to store a value inside a variable which is unsigned integer. So, first let me check whether -2 falls in the category of unsigned integer. Sir, what are you talking about? Is it possible to store a negative value inside unsigned integer? No, sir. Then, which value is stored inside a variable? Sir, in order to store negative value, just check this circle because this is of signed int. Sir, from 0, we need to move 2 steps. Then only we will get -2. But since we are working upon unsigned integer, remember the cyclic property? Sir, do the same in this circle. From 0, move 2 steps. So, if I move 2 steps in anti-clockwise direction, what is the value I get? Sir, we will get 6, 5, 5, 3, 4. That means, what is the value that gets stored inside A? Sir, 6, 5, 5, 3, 4. Okay, sir. Now, if I perform complementation of A. Sir, we know the complementation of any variable is nothing but minus of A plus 1. That means, sir, it is nothing but -6, 5, 5, 3, 5 or 6, 5, 5, 3, 4 plus 1. That is minus of 6, 5, 5, 3, 5. Now, that means you are trying to do something like this. Printf %d, comma, -6, 5, 5, 3, 5. See, what is %d? Sir, signed integer. Sir, does this value falls in the category for signed integer? No, sir. See, -6, 5, 5, 3, 5 does not fall in this category. Then which value will be printed? Sir, let me check. See, in order to print this value, sir, in order to print any negative value, we need to move that many steps in anti-clockwise direction. If I need to print -3, 2, 7, 6, 9, that means I have to move 32,769 steps from 0 in anti-clockwise direction. That means what is the value? Let's see. Sir, till 0, from 0 till this point, how many values we have covered? -3, 2, 7, 6, 8. our value is 1 more. That means we will move 1 further. So if I need to print this, what is the value that gets printed? This. Similarly, in order to print this, sir, we need to move 65535 value in anti-clockwise direction starting from 0. That means what I am trying to say is, sir, from here, move 65535 value. So see, if I move 1, I will reach -1. Sir, that means 65. See, what are the total number of values in this circle? Sir, the total number of values in this circle is 65536. So if I move 65535 values, where will I reach? 0 or 1? Sir, at 0. At 0 or 1? Sir, at 1. If I move to 0, that means I covered 65536 value. So, sir, what is the value that gets printed? Sir, the value that gets printed is 1. Sir, that means the logic is same. Sir, -2 complementation. What is the value? -2 plus 1. That means minus of -1, which is +1. Done, sir. So, same is the concept for 40. Same is the concept for 40. That means, sir, what will be printed? Sir, -40. If you provide complementation, what is the value? -40 plus 1. That means minus of -39 plus 39 will be printed. So, that is our answer. I strongly recommend, please watch this video again. Sir, what is the answer? Answer is option B. Beautiful question. Beautiful question. Answer is option B. Sir, let us try to solve question number 21. Let us try to solve question number 21. Again, I strongly recommend, first solve it by yourself, then only we will discuss it. Okay, sir, what is the value? Sir, x is equal to 2. X is equal to 2. That means, what is the binary for x? What is the binary for x? Sir, the binary for x is 1, 0. See, let us consider integers of 8 bits. Why to bother? Sir, what is the meaning of this? What is the meaning of this? If I have any variable and if I perform bitwise AND with 1. Sir, why this is done? Why this is done? Let's see. Sir, let us suppose I have any binary number. Sir, that number could be odd or that number could be even. In mathematics, a number of type 2x is said to be odd, 2x plus 1, and a number of type 2x is said to be even. I already discussed multiple times that, sir, if we have a binary number with a value x, if I append a 0, then its new value becomes 2x. And if I am having a binary number with value x, if I append a 1, then its new value becomes 2x plus 1. Think it in reverse direction. Sir, can I say, if a number is of type 2x, that means the last bit is 0. And if a number is of type 2x plus 1, its last bit must be 1. That means what we are saying, sir, 2x type is even. That means if a number is even, its last bit must be 0. And if a number is odd, then its last bit is 1. Please note it down somewhere. Sir, if a number is even, its last bit is 0, and if a number is odd, its last bit is 1. Done, sir. Okay, let me consider any number. D1, D2, D3, D4, 0. Okay, sir. If I perform the bitwise ending of this number with 1, does it matter what are the values for these bits? No, sir. Because if it is a 1, sir, please, all the MSBs still here, all the bits still here are 0. So, it does not matter what is the value of D1, D2, D3, D4. Sir, bitwise ending, if I perform bitwise ending, they must be 0. Okay. Try to understand. Sir. That means, sir, and here 0. Sir, but if a number is like this, and if I perform the bitwise ending with 1, sir, these bits will always remain 0, whether here or here. But because of this one, sir, one end with 1, we get a 1. That means I am saying something like this. Sir, take any number. Let us suppose I am counting from here. I'm counting from here, or you could write dn and something like that. Sir, if I have any binary number, that means d1 could be 0 or 1, d2 could be 0 or 1. Okay. Sir, if I perform the bitwise ending with 1, what is the result? Sir, d1 bitwise end with 0. See, since all of them are 0, till here, what we get? Sir, bitwise end, 0, 0, 0, 0 till here 0. Sir, the whole result of bitwise ending is totally depending upon what is the value of dn. Sir, if dn is 0, the result will be 0. If dn is 0, the result will be 1 if dn is 1. So tell me, if dn is 0, that means can I say the number is even? And if dn is 1, that means last bit is 1, can I say the number is odd? Think about it, focus here. That means what I am saying is, sir, if we have any odd number, and if I perform bitwise ending with 1, what is the result? Sir, if this is odd, that means this is 1. 1 and 1 is 1. That means the result will be 1. In case n is odd. But in case n is even, that means last bit is 0, 0 and something is 0. That means the result will be 0 if n is even. Done, sir. Done. So any number bitwise end with 1. If it is non-zero, can I say if it is non-zero? If it is non-zero, yes sir. If it is non-zero, yes sir. That means it is odd. If it is 0, that means it is even. Try to understand and let's try to solve the original question. Sir, see what we are saying over here. Sir, 2 bitwise end with 1. Sir, even bitwise end with 1, what is the result? Sir, 0. Even if you don't know what is the binary for 2, sir, this. And what is the binary for 1? Sir, this. If you perform bitwise ending, say 0, 0, 0, 0, 0, 0, 1 and 0 is 0, 0 and 1 is 0. That means what you get? 0. That means I am saying something like this, 0. Sir, what is the meaning of 0? False. Sir, ternary operator, how it works? If we have something like this, what ternary operator says? Ternary operator says, if it is true, then go to this expression. If it is true, the value of this entire expression is given by this. If the value is given by this, that means you have to evaluate expression 2. But if it is false, the value is this entire expression is given by expression 3. Since the value is 0, the value of this entire expression is given by this. Sir, is it an expression? Yes, printf is an expression. But what does printf do? Sir, it used to print something. That means what will be printed? Academy will be printed. That means answer is option C. Now, some of you get confused. Sir, okay, printf is printed, but printf will return something. 1, 2, 3, 4, 5, 6, 7. So, some of you think, where is 7? See, sir, the value or result of printf is the number of character printed by it. But are we using this number anywhere? No, sir. See, I always tell you something like this. Sir, these two are different. So here we have first scenario. Printf did its task and nothing. We are not concerned with what what is the result, what is the output, what is the value associated with printf, because we are not using it here. We are not using it anywhere. See, the situation will be different if we have something like this. Now this 7 will get stored inside A. But again, if we are not printing A, that does not matter and that does not make any sense. So that's how this question can be answered in the best possible way. So hope you get it. Bye bye. Take care.